Hello, welcome all of you. Today we are going to look at the Ptable. Okay, it's basically I'm going to give you a tour of how to use this ptable.com site. Okay, just www.ptable.com. Okay, so it gives you a very good picture about the periodic table. So if you look at the periodic table, the if you click anything, it gives you uh, where the elements are located very clearly. For example, these are called alkali metals. So if I just move my browser, I see that these are alkali metals, and these are called alkaline earth metals. And these are metals, and these are non-metals, and those are noble gases, non-reactive metals, metalloids, and so on. Post-transition metal, transition metals, lanthanides, actinides. So when you move the cursor, you can see that where they are located. So first thing is to see the most important ones. Now let's look at the gases. There are three states, right? Solid, liquids, and gases. You see that most of the elements in the periodic tables are solids. Okay, those are one on black. And you see that there is only two liquids in the periodic table. One is mercury and one is bromine. And you see that there are several gases here: hydrogen, nitrogen, oxygen, the ones that is given in red, nitrogen, oxygen, fluorine, chlorine, and all the ones at group number 18, helium, neon, argon, krypton, xenon, and radon. And the best thing is to memorize, at least for the honors chemistry or general chemistry, you have to memorize the first 30 elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur. Like that, you have to memorize the first 30. If you're taking AP chemistry, it is better that you memorize till 54. Okay, that will help you, because the reason is the names of these elements sometimes will not match the symbol. Like for example, if you take Na, the Na and sodium does not refer. So sodium is natrium. That is the reason the symbol is Na. Like if you take antimony, it is given the symbol is Sb. Okay, it is stibium. Like for tin, it is tannum. Okay, it's Sn, and so on, and like that. So the names sometimes vary. Okay, so iron is called ferrum. Copper is cuprum. So you have to remember some of these names based on these, not the symbol, but their origin names, right? Even for the simple one like potassium is K, is because of kalium. So you should remember this, and so to have some good idea, you have to memorize this. Okay, that is number one. The second thing is to know that the metals are all on the left side, and all the non-metals are on the right side. Okay, and the noble gases, group number 18, they are non-reactive. They are not at all reactive species. There is a reason behind this. And the reactive non-metals, very reactive ones, okay, are gases. Okay, they react very fast. Okay, and one of the anomalies, hydrogen is in the first. So this entire periodic table is differentiated in groups like group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 18. And there are periods 1, 2, 7. Now to look at this, if you click any element, it shows the symbol, it shows the atomic number 3, and it shows the mass number 6.94 for lithium. So you see for any of the element, if you click any of them, it gives this. This is under title properties. It gives you everything. The name, and then what is the state at 0 degrees. We want at 25 degrees. Okay, so if you type at room temperature, you can find out that So 25 degrees. What is the temperature? Is it a solid or something? And then weight. We are going to learn more about this energy levels, all these properties, electronegativity, and all those things in the atomic structure. And all these, what is the meaning of these properties, like electron affinity, ionization energy further. So, but it gives you all the values for all these elements. Okay, that's what we have to know. Okay, so it gives you for each and every element what is the melting point. Okay, what is the melting point of that substance. If you click this electrons, it tells you how many electrons are in each of the orbits. Okay, so we are going to look at the electronic configuration later on, and it's going to tell you what are the electrons. And each and every element has its own isotopes. So you see that if I click that, it shows that beryllium has so many isotopes. Hydrogen has so many isotopes as well. So how these isotopes are formed, okay, so though that's a different chemistry, okay, so that we are going to look at this one. So this is a compendium of so many information that is given here, and so many informations or relative information about nuclear chemistry is also given here. And if you go and hit compounds, you can drag two elements and see hydrogen and oxygen and see how many elements can be formed within hydrogen and oxygen. Or you can just keep only oxygen and see how many elements oxygen can form. If you drag carbon and see how many elements carbon can, millions of compounds carbon can form. So you can try to find out some of the elements that, what are the elements can form. Like take helium. Helium does not form any elements. They are unreactive species. So you can find out what forms compounds, what does not react, and so on. So this is a way of looking at the periodic table very closely. It's a very interesting site where you get full access of the full information. That is number one. Number two is you hit this like wide, the periodic table becomes much bigger. Okay, so basically if you click one more time, it becomes smaller. So you see that the elements after 56, 57 to 71 is given here, and 89 to 103 is given here. They are supposed to be inside this. The real periodic table should look like this. Okay, to constrain the space, we are putting this as smaller version, putting that down. So these are called S block elements because the outermost electron comes at the S block. And these are called P block elements. These are called D block elements. And these are called F block elements. S block, P block, D block, and F block. So that is the reason we call these elements as called the transition elements, because they transit between left side and right side. And this at the towards the end, we call post transition. We call this at the bottom as lanthanides because they follow lanthanum. And the bottom is called as actinides because they follow actinium at 89. So this whole thing is a full information. So many information are given here, but this is a good resource to use all the time. So if you have want to have any information about any element, you just come here and look at it. Okay, if you want to know anything about manganese, okay, so you just go and hit manganese, and then you can read about manganese in the Wikipedia and try to understand how manganese looks like, how to read more about those compounds, those elements. So this is a very good site to look at, to understand about the properties of these elements. And there's so many information is given here about electronic configuration, how many isotopes they form, how many compounds they form as well. Okay, so this is the thing that I wanted to show you, to use Ptable as a resource. Okay, just not to use for answering questions, but to understand how many things you have. Okay, because when we go for the atomic properties and we learn about the like radius, electronegativity, and melting point, or the ionization energy, and many things, we are going to compare the values from here and try to understand by which you can compare the data and try to understand this in a much better fashion. Okay, so this will help us. I believe this will help you for your classes. Okay, thank you.